Nice. So the simplified form of this. So where did the 4 come from? Because I don't see any 4 here. Good, good. You factor 3. Excellent. Oh, I love the vocabulary here. Yeah, so basically you have to factor that 3 out. In the previous example, you didn't have to. Oops, I already erased the previous example. In the previous example, you didn't have to. It was already factored. So yeah, the 3 would now come out, make that 2 into a 6, and now we have that. Okay, excellent. I'm going to give you all one more. How many of you are there today? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of you. I think if I have you all writing on the board at the same time, at least one person will go insane. So let's just try this private message. Okay, private message your answer to this. That way only I will go insane. And let's be honest, who'd notice? What would the simplified version of this be? -4, -2x plus 1 plus 3. Private message me the simplified form of that. -2. That's it. So now you got to ask yourself, what would I have to distribute -2 to get this back? Obviously the x would have to be first, but first of all, in order to get a positive number here, I have to multiply this negative by a negative. That's the first thing. And what would that number have to be? Well, always just take this and divide it by that, a half. Okay, have a look at that and convince yourself that if I distribute -2 over that blue bracket, I'll get what's inside the absolute value. So that's a crucial first step, and I think that's where some people went wrong. So all of this stuff stays the same. Now the -2 comes out and gets absoluted. So my new number, factor it out. And then make sure that what's in this bracket actually works when you distribute. Yeah, it doesn't have to be a whole number. We can have vertices anywhere, right? They can occur anywhere on the graph. I'm glad you said that, Tyler. That's probably an assumption that a lot of people make, and it's probably because most of the examples I give you, let's face it, they have whole numbers. Okay, so by the way, if I had asked you right off the bat what the vertex for this was, you might have been tempted to say, oh yeah, -1, 3. Would that have been right? No. The 3 would have been right, but the actual h was +1/2. So this time I'm going to give you one, and all I want you to tell me is what's the vertex. Actually, no, forget that. This time I want you to give me the rule again. All right, let's try it via chat this time as opposed to private message. I'm going to load this puppy up with as many negatives as I can. So let's see, -5, absolute, -2x minus 3 minus 7. Wow, that's about all the negatives I can fit. All right, simplify that. Be tempting to say, oh yeah, 3. Well, we ended up with a rule with a -a, didn't we? Yep, so it would open down. All right. Safer to figure that out. Well, actually, oh, we could have figured that out just with the original A, right? Because this won't have any influence. We saw that the B doesn't have any influence. All right, cool. So that's one little detaily thing I wanted to go over is make sure you factor out that b if it's there, and especially if you're looking for the vertex or if you're simplifying the rule. All right. Next, I want you to, I'm going to give you guys an equation to solve. Solve this equation. Let's see, 5 absolute, x plus 1 plus 10 equals 0. Solve that for x. I'll give you 2 minutes. Try it on paper. And don't private message me, okay? Just hang on to your solution. If you sketched it, you would see this thing never is equal to 0, right? It opens up and it's got a vertex above. It's got the positive a and the positive k. Remember that? That's how you got the no solution message to show up on your GeoGebra. Yeah. So did anybody actually go and solve it like this and end up with x plus 1 equals negative 2 and then keep going? Because if you did, that happens a lot. Good. When you saw that at this point, this is where, you know, the algebra tells you, but the algebra here just whispers it, right? It doesn't, it's not like the quadratic, where the quadratic was like no solution because you can't square root a negative, right? But there's nothing stopping you here. The algebra is just saying, psst, you know, hey kid, hey, but it's not yelling it at you. So yeah, this is where you stop. Make sure you check for that. Now I'm going to give you another one. Maybe this one will have a solution, maybe it won't. I don't know. I don't know. Be careful. Before you do anything, predict. Will this have a solution? Yes or no? All you gotta do is do a quick check of the A and the K. Remember, that's all that mattered. They're opposite, therefore, yes. Proceed. Don't private message, just work it out. I'll give you 1 minute. Correct. Don't look up here unless you're stuck or done. All right, if I get 0.5 or about negative 1.2. Excellent. Questions? Problems? Let me ask you this then. Did you have to factor out the 3 here? Like, did anybody notice that 3 and say, ooh, that's a B? I gotta factor that out. Yeah. It's not wrong to factor it out, but for solving an equation, it really doesn't matter. It really only matters when you're looking for the vertex. That's really the only time. But like I say, it's not wrong to factor it out here. You should get the same solution. Okay, questions about this one? So the detail I wanted to mention is watch out. Sometimes there's no solution. It's really easy to miss. Now let's talk about, oh, sorry, the 0.5. Oh, and I just erased it, of course. Sorry, folks, what was the equation? I don't even remember my own equation. -5, 3x plus 1. I ended up with this, right? 3x plus 1 is equal to 2.5. Okay, sorry, thank you. So we do 3x plus 1 is either equal to positive 2.5 or 3x plus 1 is negative 2.5. So this gives me 3x is 1.5 and I divide both sides by 3. There it is, 0.5. Does that make sense? You're welcome. Okay, anything else? Are we good? Okay, last little detail-y thing is inequations. Okay, based on that assignment, inequations are still a big problem. I'm going to ask you all to solve on paper this inequation, if possible. Hint, hint, hint. Absolute x minus 2 plus 1 is greater than or equal to 0. What, Tyler? Wait, what? The a and k are positive, yeah, The a and k are positive, so if this were x minus 2 plus 1 equals 0, yeah, there'd be no solution, right? But this isn't just equals, we're looking for where it's greater than or equal to 0. So let's just try out, Joelle, you had 3 and -3. Let's try out 3 and let's see if it gives a true statement. Is absolute 3 minus 2 plus 1, is that bigger than or equal to 0? Yeah, actually it is. This comes to 1. This comes to 2, and that's so 3 is a solution. And you got -3 as well, Joelle. Let's try -3. -3 minus 2 plus 1, that gives me absolute -5 plus 1, which gives me 5 plus 1, that's 6. Yep, that's bigger than 0. -3 is a solution. You know what? Any number knows. That's part of the reason, Joelle. That's part of it. What I'm drawing on the board now is a big hint. If you looked at the graph of this thing, yes, that's it, Fino, that's right. This function, absolute x minus 2 plus 1, you're right, it never crosses the x-axis, but this question isn't just asking you where it crosses the x-axis, it's asking you where is it above the x-axis. And as you can see from the graph, it is always above the x-axis. Now, did the algebra tell you this, or did the graph tell you this? Who told you this? Who told you this amazing thing? There you go. No algebra needed. I mean, how many math teachers tell you, stop doing algebra? I'm telling you, there are times when it just isn't worth it. So the solution to the, oh, sorry, is it 3? Thank you. Yes, it is. I did that on purpose just to see if you were well done, Tyler. Yeah, so yeah, the answer to this, the fancy way that you write this is this way, okay? You say x belongs to the empty set. So watch out. I'm just saying, I might toss something like that in there just to see who's really, really on their toes. Which should be everybody, by the way. All right, I'm going to stop talking. And if you want, I will put you into a breakout room where you can further study on your own, or you can stay here with me and ask me questions, just like tutoring, which, by the way, 7:30 was the only time anybody showed up for tutoring, but anyway. Or you can stay here and I can ask you questions. Okay, so tell me what you'd like to do, and we'll get started on the board. Find the rule of this absolute value function. All I'm going to give you is 3 points that belong to it. Let's make this one 2, -3. And this one 8, -3. And this one 7, 1. Find the rule of the absolute value function that will go through all 3 of those points. I'll give you, I think you're going to need a good 3 minutes for this. And if you have no idea what to do, just watch, because I'll start doing it on the board in a second. Otherwise, don't look. Hello, my love. That's a candy apple? Answers. So it comes to -4x minus 5 plus 9. How I got the a? Okay, so the a comes from the slope of one of the 2 sides, and the only side I can find the slope of is this one, because that's the only one I have 2 points for. So I found the slope by doing delta y, 1 minus -3 over delta x. It comes to -4. Now then you have to just check, like, for this is the a for the line, but then pick your a for your absolute value by, noting, okay, it opens down, so yeah, I'm going to keep the -4. So that's what goes into the rule. Okay, any other questions? Okay, cool. Could you have used the slope on the left? Well, yes and no. The only problem with finding the slope on the left is that I only had 1 point on the left side. So I couldn't have calculated the slope just from that 1 point. Do you know what I'm saying? But could you have plugged in +4 into the absolute value? No, definitely not, because we can see from the sketch that it has to be a -a. So you have to put in -4 for the absolute. Does that answer your question, Tyler? Yeah, okay, cool. All right, let me give you guys another one. Let's see, let's mix it up. I haven't talked much about, you know, those operations on functions and things like that, so let's try one like that. Okay, good. No, it's a good question. Excellent question. Let's say I've got f of x is an absolute value function, and g of x is, oh, I don't know, it's a quadratic. Yeah. What do you suppose the rule for f composite g would look like? What? Try it. I'll give you a couple of minutes. Again, I'll do it up here, so only look if you're stuck or done. Is to square the x, and then whatever you get from that, you add 9 to it. So yeah, that's about as good as this one gets. What about this? If I'm going to draw a graph, I'm going to try to draw a graph. Let's say you've got a function that looks like this. Let's say this is f of x. Then what would the graph of f inverse x look like? Remember, that's what happens when you reflect in the line y equals x. Anybody want to volunteer to draw that for us? What would that graph look like? Thank you, Tyler. You have tools? Well, even if it isn't, we'll figure it out right here, right now. That's it. Exactly. I mean, more or less, you know. Probably in reality it would be more like here, you know. But yeah, that's the basic idea. Oh, now I have to move all the little, oh my gosh. Oh, Zen. Yeah, good. Excellent. C'est ça. Alright, I guess I better bring everybody back. Just gonna drag you guys one at a time. Alright, so good luck tomorrow, everybody. Unfortunately, I can't make myself available for tutoring, but if you have a quick question, you can tweet me. I'll check my Twitter feed sometime tonight for sure. Alright. Keep working on those consolidations. Do look at those exam questions. Even just look at the solutions. They're all there. You never know. You never know. Okay, bye everybody. See you on Friday. Good luck. Bye-bye.